Covered in the UML background module is UML2 superstructure, comprising structural and behavioural elements and auxiliary constructs. We're going to look at UML behavioural constructs in UML best practice technology. These behavioural elements include use cases, sequences, activities, state machines, and diagrams. Not included in the UML spec, requirements modelling is nevertheless a capability of best practice UML technology. In the enterprise context, recording of functional and non-functional business requirements is essential. UML expressions can be mapped to business requirements. UML elements can be traced to a particular requirement. By the way, I'm using Sparks Systems Enterprise Architect. One of the capabilities that I like is the ability to read requirements indirectly from a spreadsheet, and EA includes a tracking mechanism so that a model can be traced from concept to code. It's good practice to use the UML realization connector to map elements to requirements. Functional requirements can be categorized as business rules or business logic, and features, functional behavior, which provides a result. User interaction with the system is a great place to start modeling behavior. The UML use case element is very useful. Actors are used to illustrate the different business and technical roles within the enterprise. Use cases provide a simple functional view of system behavior. A communications overview is another useful construct, as are interface diagrams. A business process model can be used to identify system runtime behaviors. Events and sequences are the UML constructs to illustrate activities. To advance the cause of model automation, although not a UML construct, the BPMN, or Business Process Modeling Notation, builds on activities, sequences, and events to generate workflows. As well as describing business behavior, UML behavioral constructs are really useful for describing technology sequences. System use cases generally specify user interaction behavior. From an ICT development point of view, the terms in the language reflect the technical context. The elements, diagram, and profile are the same. Of course, technology behavior can be very well described by sequence diagrams and state machines, which incorporate the concept of transition from one state to another, allowing for representation of initial, intermediate, and end informational states. Modeling system behaviors with UML is a prerequisite to modeling technology architecture requirements. From an enterprise architecture point of view, technology infrastructure specification is essential, particularly in view of deploying to a cloud platform. Having easy-to-read diagrams of system behaviors makes it easier to generate test plans and test cases, as well as understanding scheduling dependencies for architecture input into project management plans. Clearly expressed ICT system behaviors promote good communication amongst business owners, analysts, developers, architects, and last but not least, data center operators. UML behavioral constructs go a long way towards enabling system automation from a technology model.